This is our cart presentation.
Akina Maxwell.
CJ Stevens.
And Hunter Showbaum.
All right, project description. We created a cart bumper to lessen the impact of the crash after rolling down a hill. We're going to analyze the results and redesign the cart and propose the concept of the bumper. This is how we set it up. We started from a distance of 102 centimeters. That's 1.02 meters from the back start of the track to the stopper. The height of the start was 7 centimeters. That's 0.07 meters. And the mass of the cart was 293.76 grams, which is 0.29376 kilograms.
So this is the first trial, and you just click on the link, and it'll come up on YouTube.
All right, so in the first trial video, you saw the impact with the force sensor, and we found the max impact of the force to be negative 11.7 newtons. As you saw, the impact with the stopper was very quick and had a large repulsion force. So we used the mass of the cart, the length of the track that was traveled, and the height of the track along with gravity to find our potential energy so that we could find the velocity we should have before impact without any kind of friction. So our potential energy was found to be 0.202 joules, and our velocity before impact should be about 1.2 meters per second. It's probably a little less because of friction, but that's without friction. And then acceleration after impact was found with the motion sensor, and that was negative 9.964 meters per second squared. And so there's the graph of the first trial finding the acceleration, and we used a linear fit to find the acceleration once the direction changed on the graph.
So for the bumper creation, we take a piece of cardboard to the front of the cart, and then we added packing material into the front of the cardboard, and then we added an additional piece of cardboard into the front of the packing material. And this is the second trial. You just, same thing, just click the link.
So after you watch the next video, you can see the recording that gave us the data in the second trial analysis. So we had a substantially less strong impact on the force sensor. It was calculated to be negative 5.8 newtons, which is decreasing by almost 6 newtons from the last one. It still had a little bit of a backwards acceleration after the impact. Crash was still pretty quick, and the force of the crash was the only thing that was really improved on. It still was about the same acceleration moving backwards after the crash. There's a little graph of the force detector in the bottom right corner. The peak of it is where we found the strength of the force to be negative 5.8 newtons.
So the redesign, to make the bumper work better, we trimmed some of the cardboard to make the car itself lighter, and then we wrapped that cardboard around the cart in bubble wrap to increase the surface area and that added padding, and then we added more padding to the bubble wrap. And then this is our third trial, and you just click the link.
So in the video, you'll see where we got our third trial. So in the third trial, we got negative 5.1 newtons of force, which once again is decreased from our second trial. Not by a ton, but there was a decrease. And then once again, we did the potential energy calculations with our new mass of our cart. That includes the weight of the bumper and still the height of the track and gravity. And we got 0.203 joules, and the velocity before impact was about the same. It was 1.2 meters per second. That's theoretical still. And the cart had less movement after a slower crash compared to the first. And once again, there's our graph in the bottom right corner. The peak is where we found the impact of the force to be.
All right, the proposal. So we decided to make the design lighter and add surface area to the bumper. We're also going to add padding to the bumper and make sure the weight is balanced so it doesn't tip over when it hits the end.
So our conclusion is the bumper that we created eventually decreased the force of the crash after we went through it 3 times, but the velocity remained the same, so the speed of the cart remained the same regardless of how much we added to it, and the time of the crash overall decreased.
Thank you.